ship of Theseus is famous for its experiments that go something like this. Say there's a ship, and its planks are gradually replaced. After a long time, every part of the ship has been replaced. The question then is whether the restored ship is still the same as the original one. This is a great question. Unfortunately, I'm not a philosopher, and I'm only here to explore the chemistry, which is why today we're going to do something similar, except with copper-2 sulphate crystals. Step 1. Dehydration. Into a small beaker, I added some copper-2 sulphate crystals, followed by some concentrated sulfuric acid. Not much seems to be happening at first, but as I continue stirring, the blue color of the mixture slowly fades. The concentrated sulfuric acid serves as the dehydrating agent here, pulling the water out of the crystal, thereby rendering it into the white anhydrous salt. The acid was then removed through decantation. I then added some distilled water to redissolve the solid and form the blue copper-2 sulphate solution. Step 2. Electrolysis. I connected some copper to the positive electrode of a power source and immersed it into the solution. I then connected a forcep to the negative terminal because it doesn't really matter. When I turned on the power source, a lot of gas bubbles evolved around the forcep, and it is gradually coated in brown deposits. During electrolysis, the copper in the anode is oxidized to copper-2 ion and dissolves into the solution, while the copper-2 ion in the solution are reduced and deposited on the forcep as metallic copper. After a while, the copper in the anode is completely consumed, so I swapped it out for a new one. The process was then repeated for half an hour to ensure all the original copper-2 ions have been replaced. Step 3. Double displacement reaction. I performed the gravity filtration to remove any leftover copper and obtained a clear solution. I then added an excess amount of potassium hydroxide solution to it, and the black copper-2 oxide immediately precipitated out of solution. I performed another filtration to obtain the oxide, and discarded the solution containing the sulphate ions. After that, I transferred the black paste back to a beaker, and reacted it with a slight excess amount of dilute sulfuric acid to regenerate the blue solution. Step 4. Crystallization. I let the solution sit in room temperature over the course of a month or so, and let the water slowly evaporate. As the volume of the solution drops, the solubility of the sulphate decreases and crystallizes out of solution. When I finally felt like editing, I manually transferred the crystals back to their original container. A filtration probably works better, but whatever. In the end, I'm left with the same crystals that I started out with, but not really. There really isn't a point to this video, I'm just bored.